Hello and welcome to the second web seminar in June 2024, here from the Heart of Hydraulics in Lohr am Main. My name is Stefan Lehnert and I will be the host for the next 45 minutes. And together we will talk again, I would say, about H4U, Hydraulics for You, and how the journey continues. The first one is already here. Hello, Florian.
Yeah, hello, Stefan.
Florian, you know, maybe it's a little longer ago, we talked about something different. We talked about the Size and Select Assistant and sizing itself within the Sitronics products. As I said, 7 months ago, we had the colleagues here, Arthur, talking about H4U. So 7 months later, I know this is a fast business. What has changed?
Yeah, what has changed? So at the beginning, a short introduction to myself. So my name is Florian Zang and I'm the software product manager for this product. And what has changed? So today I want to present the new product increments, what changed since the last year, and also want to give you an update, an overview about the benefits of our new H4U software platform.
Okay, so software platform. For me still, as we are hydraulic guys, hydraulic is oil, it's noise, it's heavy weights. Now a software platform, how does this fit in? What is the idea behind that?
Yeah, you're absolutely right with this question, and I could give you an answer to that, but I think we found someone who gave a better answer to that.
Okay.
And for that, we prepared a short video from our senior vice president, and yeah, let's see what he said.
Industrial hydraulics is in the middle of a transformation process from hardware more towards software-based hydraulic functions and digital services. And with our new platform H4U, we want to further increase the competitiveness of our customers. The apps that we provide with the platform creates value along the whole product lifecycle, and the customer can increase both productivity as well as sustainability. H4U as a platform is a milestone in our digitalization strategy and of course the base to further broaden our digital portfolio in the future.
This was quite the answer, right?
Yeah, right. So Guido Hedwer answered and said it's an important step for us to go into the direction to get or to become a digital company.
But so how do we approach it now today? I think you have a little bit to show. Let's say you have some news, I would say.
Yeah.
So, but also, as we are doing is with this live web seminars, we want to have a real kind of application demonstration. Is there something prepared from your side?
Yeah, at the beginning I have a general overview and the benefits and the architecture, and then I will present the new products what we have. So we have position and force control with alternating control, synchronization control. We go a little bit into the details to that you have a feeling about that. And at the end we prepared a demo to see how it feels and looks like.
I think we're really looking forward to this. So yeah, maybe again, let's start with the platform itself. I don't know if everybody's aware about it.
Okay, let's start. Yeah, what you can see on this slide, on the right hand side here, it mentions that with our H4U software products, we can run really on several devices. So we are hardware independent. So this is what you can see at the bottom. Our knowledge, what we have in the hydraulics, you could see, and this is only an example. So everything where we think that we have a big knowledge, we can put into the software, and then we can decide to bring that to several devices, or even we can bring it to different controls, PLCs, and also into cloud services. This is a general idea of it. So yeah.
And, I'm sure it has a lot of benefits and you will talk about it, but now it's again time for an interaction part. We would like to have your answer on what are the most important features of a hydraulic software product today. So is it the functionality, maybe the price, the ease of use, or the flexibility? What will be the most crucial feature you're also willing to pay for, I would say? Let's wait for some more seconds. We have 70 people in, 23 answers yet. It's quite close. Again, like in soccer yesterday, it was crazy. Okay, 35, so 50% voted. Interesting, very interesting. We talked about this in the preparation. It looks like the ease of use. I think that's what you said. It's a very big element, but the price is not the biggest one.
No.
And even it's the last one. So that's interesting. So ease of use, functionality, and flexibility kind of on the same level, and then the price. That's a little bit surprising, I would say.
Yep, it is, yeah.
Okay, but what would you say, from your perspective, what are the biggest benefits of using this platform? Is it the ease of use? Is it flexibility?
It is one very important point for sure is the flexibility, because with this software function blocks, we allow you, and this is what you can see on the left-hand side, we allow you to integrate our functionality in your control PLC system. And with that, you can control your actors and can read in your feedback signals, your sensors. And yeah, so you are more flexible, you can choose. So you can, it's not a must to do that, but it's the additional way how you can do it in future. In the past, in the most cases, we brought our hydraulic functionality with our devices, but now we enable you to put this functionality also to your machine concepts, and this gives you more flexibility. Yeah, and yeah, for sure, you can use your existing machine control, and for that we reduce also efforts during the engineering phase, and this saves you a lot of time, because yeah, I think your employees in your companies, they are aware of the engineering tools, and they don't have to learn a new tool about that. Yeah. And last of all, a very important point is we have prepared our function blocks, especially according, and they fit perfectly to our hydraulic components, especially valves or cylinders or pumps. And so we have something like a database in our function blocks where we can communicate to each other. Yeah, good. Then in the next step, let's have a look where we what is new in our platform. This is what you can see. Last year we started with the first webinar on H4U, and there we had the PQ, so the pressure and volume flow control integrated, and now we come up with two new product increments. So you can see the XF, so means position force control with alternating control. And the second new product increment is the synchronization control for single axis. And today, yeah, we go deeper into that two topics. This is the main focus on that. And on the right-hand side, you can see why we did this and for what different control systems this are available. So Siemens, Beckhoff, Codesys, version 3 based systems. And yeah, and everywhere we have the same functionality. So the look and feel. Also, if you were to change the technologies, then it looks equal.
So what we see here, now this is the news compared to the last time. You have new products in, as we say it. But I see also some icons with 3 dots. That means you're not ready and you're not done, I would say. My question would be, how would you decide for the new functionalities, for the new products on this platform?
Yeah, this is, like you mentioned, it's only a starting point where we had some customer feedbacks and customer interviews. And with that point, we started where we thought these are the most important functionalities, but we are not at the end. So we need your feedback, I would say, to know what could be the next steps on the roadmap. Yeah. Exactly, and this is, I think, the good moment, because we don't have any input right now. There's a chat function in Microsoft Teams. You can use it. We will have Florian and also another expert here today answering your questions. Maybe you have already ideas. So please use this chat functionality, and yeah, let's make it a little more interactive if you like. Okay, so what will you do next? What would you say? Let's start with the first one. Yeah, let's look to the position force controller. Okay. Yeah, here you can see in general the control concept. Yeah, on the left-hand side, you see that the XF function block is integrated to the PLC application. On the right side, you see 2 general actuator topologies. So it is possible with this function block. It supports that. that you can control valves and cylinders. This is typically an application, but also it allows us that we can use as an actor a frequency converter or a pump to control position and force of a cylinder. Yeah. So maybe the question came up why we have special requirements to a hydraulic controller structure. And on this slide, I prepared some general things to give you the feeling why we need to take care about some special behaviors in the system. And I think the general topics, what you can read here, it influences really the control structure. So because we have a wide range of application requirements, it could be that we must position accuracy could be millimeters or some millimeters down to some micrometers. So a big range. Also the velocity could be 10,000 millimeter per second, go down to 0.1 millimeter per second. Also the force can have a big range. And these are a lot of things we have to take care in the control system. But also when you see it here on the right side, the hydraulic system by itself has some special things to take care from the system. So the direction-dependent behavior of the cylinder, or it depends on the mass, what is mounted to set the length of the lines here, and also according to the valve. So the valve characteristic influences all of that, and yeah, everything is taken into account of our control structure.
Thanks for this. I saw a presentation some time ago where you talk about the best-in-class hydraulic control. Based on this, or how would you answer the question? What makes you best of class here?
Yeah, for sure, we have some big benefits of that, and for that to answer that question, I brought the technical data with me.
Yeah, we have engineers in, so I think
I don't want to go too much in detail to that, because at the end I have linked the you can find a link to the complete data sheet, and then you will see all this data. But I think three very important functions what allows you to handle your application in a good way is for sure the position force control with the alternating control. Really with the smooth switching between position and force, this is a very important feature. Then for sure the state control. So if you have application cylinders with a low frequency, this allows you to handle this application and to make the control in a good way. And last of all, I would say the component database is a very nice feature, because you see only a short overview about the different valves and pumps what we have, and it's easily that you select one component out of this database, and you can save time during the commissioning and you have not to put in so much parameter.
Okay, quite valid points, I would say. These technical data is just an excerpt. I think you have a big data sheet available already at the end. I think we will show where you can find it.
Yep.
So thank you for this. So this was now XF. There's another one, SC, sync control or synchronization?
Synchronization control. Yeah.
So what about this one?
Yeah. I think it could be very complicated, but this picture gives a good overview of what it does, and then you can really understand it in a good way. So the synchronization control is every time then possible when you in your application need to move several cylinders. And in this example, you can see what could cause the issue or the problem when you take not care about a special control of that. So you can see in this application on the left-hand side, you have 1 ton. On the right-hand side, you have 100 ton. So it means the cylinder or the control on the right side must control or must open the valve more than on the left-hand side. And if you do not take care about that, then you will get a higher deviation. And sometimes in your application you don't want that because mechanical mounting, you only few micrometer are allowed or whatever. And for that we have a special synchronization controller which solves this problem and helps you to make really a synchron movement to your hydraulic cylinders. Is that you have a feeling how this operating principle works, how you will integrate that. So you can see that First of all, we need for every single axis a standard axis controller, like position force controller. And if this works fine independently, then in a second step, we integrate to our PLC applications the synchronization controller. And this is like a master. It controls then the slave axis below. And yeah, and this minimizes the synchronization error, even if a different load is distributed on your application. Good. Maybe you are wondering that the range, because the range of applications could be completely different and the requirements would be completely different of synchronization mode. And for that, we have some important modes integrated to this functionality. I don't want to go too much in the details, but that you understand that there are, or that you know that there are some different ways how you can solve your application tasks. So one principle would be the master. So every time one axis is the master of that. Then a second principle would be if the minimum principle. This is typically used when you have elevators or lifting platform applications. The maximum value principle is when the cylinder comes down from up to down. Something like in presses, this is typically used. And then this is also a special mode, the mean value principle, used in presses where we have displacement synchronization. So it is a synchronization mode positioned together with forced, yeah, and special for press applications. Mm-hmm.
I like that you show these application examples here already. I think we will have a specific one in some minutes. So this was a lot of info, I think, yeah. A lot to digest. That's why I would like to stop for a second and have a look at the chat. If there are some questions coming in. All right, right now I don't see any, so it looks like people have to digest, as I said, but yeah, I'm sure you also have technical data here.
Yeah, it's the same like we have it for the position force.
Okay.
So you can see it here, also some important things like the position control, but you can also find it at the end. The link is there, and then you can have also detailed information.
So we have about half time now. So yeah. It's time for a half-time break, I would say, talking about soccer again. So you said you want to demonstrate it a little bit more. How would you do it?
Yeah, so we prepared something, but I don't want to do the demo. So for that,
I see somebody waiting in the background. Hi. Hello, Thomas. Thank you, Florian. We will get back to you in a second.
Hello, Stefan.
So I think you're fresh, a new face for the audience here. A friendly face too. Could you say a little bit about you, what you're doing in the company, and especially in the area of H4U?
Yeah, exactly. I'm the Thomas from the software development engineering department, and I'm responsible for developing this H4U software functions.
So now I understood you want to demonstrate something. I'm missing a little bit. Normally we have an exhibit here. So how you will do it today?
Yes, exactly. Usually we show our software when we have some cylinders and some pumps, and well, this is not possible here in the small cabinet. We have therefore I brought a virtual cylinder with me, and with these virtual cylinders I will show the position force and the synchronizing control app.
Talking a little bit, just a short second, because I know it's a hot topic also on the Hanover Fair and throughout, talking about virtuality in engineering, or virtual engineering. What is as you're an engineer, I would be really interested in what does it mean for you?
Yes, well, virtual engineering is quite a big topic. To put it simply, it is using digital and simulation tools to optimize and commission your systems. In our case, hydraulic systems. And much more easier, I call it, I have my cylinder on the desktop today.
Okay, so demonstration and commissioning, I think that's the perfect words for your demonstration, right?
Yeah.
So let's see, let's start with it.
Okay. So for today's demo, I brought the following hydraulic system. In the overview, you can see two valve-controlled cylinders, which are in position and force control. And the respective cylinders are controlled via our H4U app, position force control. Both cylinders are additionally controlled by the H4U app synchronizing control. Together, this forms the position synchronization. The cylinders and valves are simulated in real time on our controller via our virtual axis module, and together with the apps form the overall demo system. The virtual axes provide the following sensors: pressure in chamber A and B of both cylinders and the position of each cylinder rod. The valve and its sensors are not considered further in this demo.
Before you start with the demo, I know that you're really heavily waiting for that. I would have a question again for you, as we don't have a chat, so I'd like to get a little more interaction. So before we go into the demonstration, 2 more questions concerning the systems. First of all, for us it's really interesting what kind of brand you're using. So if you're using Rexroth or other automation systems. So let's see what you have for us here. So 5 out of 17 out of 80. That's 27. So yeah. So we have kind of 45% of the participants. It looks like it's a very, very close race between Siemens, Beckhoff and Rexroth. Of course, we have partners in, but also it looks like even it's exactly the same amount Siemens and Beckhoff. I think they're the typical manufacturers, yeah. But also we see that Rexroth is in already. Good work by the colleagues.
Nice to hear.
And then the second question, especially concerning the integration of these systems. How do you do it already at the moment? So with your own employees in the company, or even by third-party providers, or by using Bosch Rexroth application personnel or commissioners? Let's see about these answers here. So 15 out of 80. Let's wait for some more seconds. Okay, I think the tendency is quite clear. Very lot, or 50 more than half of the participants doing it on their own within the company, but also third-party providers are in, and also Rexroth, but Rexroth is on the last place. So let's see. This is the Rexroth where you show it now.
Yeah.
I think so. Let's 6 steps. I remember from the preparation.
Yeah, it's 5 steps.
5
and
steps.
The final demo step. Yeah.
Okay, so let's start with the first 5.
Yeah. I would like to show you the workflow to integrate the H4U apps in a few simple steps using the Position Force app as an example. The overall application is then visualized, and the behavior of the system is tuned via controller optimization. And first, my first step is to integrate the app into our engineering environment, in this case the TwinCAD 3. So we're using Beckhoff in this demo. And the H4U app is delivered in a compiled library, which in a zip file, which contains a compiled library and 2 XML files, which provide an easy to use startup parameter set. And now I install the app via the library manager, and you just have to search for the zip file and the compiled library on your file system, and then open, and the app version 1.00 has been successfully installed already. In step 2, we now create some global variable lists to get a little bit of structure. The following relevant variables for the Position Force app are created in our global variable list application. The actual force of the cylinder, the actual position of the cylinder, the valve command value to the control valve, and an instance of our H4U app Position Force on the bottom. In the next step, we create the process organization units and tasks. To illustrate this approach, I have created a PLC application with 3 POUs. The PLC program, which handles initialization and cyclic call. Initialization function block, which will be called one time at the startup. And the controller function block, which initialize the controller. Now we switch back to the PLC program. The PLC program calls the init routine once and calls then the cyclic routine of the position force app in all future time steps. The sample time was for this demo is set to 1 millisecond. So in step 4, we initialize the H4U app. We do this by setting the doInit flag to true. But before we do this, we have to provide the position force app with our valve data, which we are using, the so-called actuator database. And you can find this actuator database also in the library manager under references. And here you can see the mentioned component database, and here you can see all pumps we are right now supporting for our systems and for our software, and here also for the valves which we are using in this demo. And next, we need to provide the file path to our license, which you need to activate the app functionality. Then we write the valve data and the configuration to the inputs of the position force app instance. The default values which were provided in the XML files are imported into our global variable list init.config, which you can see here. It's just a good default set to have fast commissioning. And also the initial values for the cyclic inputs need to be provided, and we do this from the variable list init cyclic. Okay, so we're getting nearer and to the hot part. Now we want to integrate the position force app into our hydraulic control system. And the position force app offers an option of loading the component data cyclically. This is helpful for systems when you have a switching actuator or you are using several valves and actuators. For this demo case, it's not necessary, but it's nice to know. Now we come to the so-called input and output mapping. The following cyclic in and out command and actual values are needed. So the actual force value of the cylinder, the force command value, and the position actual and command value. Then we just call the FB instance of our app in line 18, and the app is already running. Finally, in the output mapping, we have the connection to the valve command of our control valve, and yeah, this closes the control loop.
So at the moment now, you said this is the setup phase. I looked at the watch. It's even 8 minutes, I think, 7 to 8 minutes. It's less than 10 minutes.
Yeah,
it's quite cool. So principally, the system would be ready, but now it's time for optimization, right?
Yeah, exactly.
What do you do there?
Yeah, I brought not just a single cylinder system, but with 2 cylinders. And in our system, in our demo, there are different loads. And I want to tune the synchronizing control to work as good as possible.
So let's see how this works.
Yeah. So yeah, finally the overview of the overall application. I have to switch to a prepared demo project. The visualization shows the cylinders with their respective pressure sensors. The different load and spring of in form of a ball, a red ball, and the possibility to set the limits on the left side, the control deviation of the synchronizing controller, and on the bottom you can switch on and off the synchronizing control, and you can tune the P gains of the controller. And yeah, the line marks the synchronizing set point. And you can see in this default configuration without the app, the error is quite high, right in the middle. And then I switch the app on with default parameters. And you already can see, well, the error is minimized by a half roundabout. And yeah, the system, as I mentioned, have different loads. So we need to tune our controller to this. And we do this by adjusting the P gains on the bottom. And first we try a number of 10. And you will already see this will dramatically reduce the position synchronization error. I do another try with 15. And there's a little bit of improvement has happened. And well, another try with 20. And you can see no significant progress was made with this set. Again, I want to compare the system with and without the synchronizing control, therefore I switch it off. And you see again, yeah, quite large positioning error in the synchronizing control, and then I switch it back on. And you see, yeah, the behavior is satisfactory, so the commissioning is completed.
Okay, so thinking about what the participants said earlier on about the ease of use, I think this is really, really easy to handle. I think beforehand it was, yeah, the back of control. I think for the expert it's also quite good, but this was really impressive for me. So thank you for this. Talking about applications, Florian mentioned several applications. What could be a possible application for this?
Yeah, a possible application could be an hydraulic lift. Yeah.
Okay. So yeah, I hope you have some ideas and some impression how easy it is, how this will work out, also about the flexibility of the system. So first of all, thank you for the demo. And again, getting back to you, we have one question came in, and hopefully you have further questions on. So now it's time for questions. But of course, if you think about how to get this information here, you will get the documentation that Florian showed, the presentation, definitely within your registration as a feedback. The demo you have to, let's say, visit to our website on YouTube and have a look maybe on this web seminar. But even better, if you have some ideas, get to your local sales or even directly contact the experts. And that's why I think let's show the overall picture. There's a lot of information online. So you can get a lot more information, including this web seminar on H4U, of course. And of course, there are the two experts, and that's now maybe the time again to also bring Florian in. They're on LinkedIn available, so you can connect them, and they will be happy to answer your questions. But first of all, I would say go to your local sales with your idea and talk it out. So looking at the questions, so thanks already, as I said. Looking at the questions that are coming in, only one from Gerrit. How far can the H4U app be compared to the HMC or MLCH? Is this something you can answer?
Yeah, so the functionality of the controller, for especially the position force controller and also the synchronization controller, is very similar to that functionality what we have in the HMC and in the MLCH.
Okay. I'm waiting for some more seconds, but it looks like it was quite satisfactory. So again, thank you. I think you showed a little bit what has changed besides the basic software platform approach. And I like the video also from Guido Hetwer, because here I think you see how important this topic is for the company. But also now real application oriented, I think 10 minutes demo. It was not too bad, including optimization. So thanks for this. Thank you also for participating today. We will have, oh no, the question coming in, so let's see. Could this software change the HMC? I don't know what this question means.
Yeah, possibly we don't plan to put the software on the HMC. it's possible to bring it into the motion logic device, but right now we are not planning on this.
Okay.
If this answers your question.
Okay. So, yeah, again, thank you for participating and having the 40 minutes on this session here. I'm looking forward to welcome you to the next web seminar, but it will be after a very long summer break. So the next one will be in October, on the 21st of October. But of course, you will get an invite as usually, or find the information on our LinkedIn channel. Thanks again. Have a great summer and see you then. Bye-bye.